This presentation is on Morrison FRP deck repairs. He spent the last 18 years of his career with Multnomah, did I say that right? County in Portland, Oregon. So please help me welcome Kenneth.
Thank you. Bruce Johnson this morning was talking about using innovative materials, and FRP definitely falls in that category in bridge application. And now that you've seen what FRP can do in the last presentation, you're going to find out what FRP cannot do when it comes to bridges in this application, at least right now. Maybe if some of the issues get resolved, it might change. Today I'm going to talk about the Morrison Bridge in Portland. This bridge was built in 1958, so this is its 60th birthday this year. And it had it's a very lightweight bridge, double bascule, and the deck on it for the last 50 years was an open steel grading deck. And for a lot of bridges, an open steel grading deck can work rather well, but for the Morrison, it had a bit of a problem. The Morrison Bridge is 6 lanes. It has a freeway feed that comes right onto the bridge. And even though it's posted 35, if you do 35 on that bridge, you're going to get somebody right up on your tail very fast. With the 6 lanes, people are wanting to change lanes. And on a steel grading like on a bridge, that can be a hazardous combination. In Portland, it rains a lot. And when the rainy seasons come, the operators on these bridges would say it's not a question of if there's going to be an accident that day, it's a question of when on those steel grading decks. After 50 years of life with that steel grading, and the steel grading was starting to have problems. We were patching it every year, starting to get cracks in the welds and just several problems. So we decided we wanted to be innovative and come up with a new deck for that bridge. And so we looked at FRP. Now this wasn't the first time Multnomah County looked at FRP for a bridge application. We actually put a very similar deck on the Broadway Bridge in Portland. And then about 2 years before we did this project, we put light rail on the Broadway Bridge, and we changed out sections of that fiberglass decking, and we used the same product in that modified application on Broadway that we actually put on the Morrison. But things turned out a little bit differently on the Morrison. But what I want to do is walk through the process of putting FRP down on a bridge deck, and then we'll talk about some of the problems we had. So this is the Morrison Bridge here. That's the old steel grading. We're tearing that deck up. The stringers there, we replaced many of the stringers under the bridge, under the deck. And so that's the process of taking up the old. And this is the process of putting down the new. So the black part on top of the stringers is a 1/8 inch thick neoprene pad that we put down. And then now this particular deck was a 2-part deck system. And what you're looking at here is the bottom part of that deck. These panels come in about 2.5 foot wide sections, and they're laid right next to each other across the deck, and then you drill through and bolt those down to the stringers down below. And this portion of the deck is about 4.5 inches thick. It's just a bunch of series of I-beams or T-beams that make up the bottom deck section. Then on top of that, we put a 1/2 inch FRP sheet. These sheets come in about 4 by 8, about the size of a piece of plywood. So it's similar plywooding a deck. And each one of those, the way those are secured down to the bottom panels is with screws. And each panel had about 120 screws in it. So deck overall, I think the estimated quantity was somewhere in the order of 66,000 screws that had to be put down. Once that's all screwed down, then we come over the top of that with an epoxy aggregate overlay for the actual final riding surface. So that's how we built this deck system on the Morrison Bridge, and that's what it looked like when we were done. And that's what it looked like after it had been in use for a little while. It looked like that for a little bit, not very long. Things started to change pretty quick. And so I don't know if you can see it. I don't have okay, so if you look right there, and this one's not very well, but anyway, you can see that one there, and you guys might be able to see some of the others. But we started to see these cracks develop in the deck. And as the vehicles would pass by, we'd hear kind of a loud slapping noise under each one of these cracks that would develop. So we got the contractor and we got the supplier of the deck system out there and to take a look at this and talk. And this was within weeks of the project virtually being complete. We hadn't given third and final note, so we hadn't actually accepted the product yet. And so before doing that, we called the contractor out there and said, got a problem, need to fix it. And the contractor and the supplier both said, you got a problem, not us. And they walked away. They said they were done. So we were stuck figuring out what to do with our deck. And so we began by chipping out next to the edges of these cracks to take a look at these screws to try to figure out what was going on. Once chipping out and exposing a few of these screws, we could see that the screws were actually working themselves loose, coming up out of the deck. And we talked to the supplier about that. And in theory, these decks, there's not supposed to be any tension force on these screws, but the reality is there is. And it was obvious by what we were seeing out there. And anytime there's any tension force on these screws, when you're talking about a hard metal surface up against something that's relatively soft with the FRP, that FRP is not going to perform very well. And so it started breaking down the FRP, pulling the screws out, and we were watching them pop up all over the place. And this problem got progressively worse as time went on. And so without the contractor's help, we were left to try to figure out this problem pretty much on our own. So what we decided we needed to do was pick up some of these top panel sheets and go in there and investigate and learn everything we could and figure out what is going on. That process required our maintenance crew to go out, and we had to locate every screw. And as I mentioned earlier, there's about 120 of these screws in each one of those panels. So with a magnet, you could find them fairly easily. So we went through, marked them out, drilled a core hole around each one, popped that core out, then we could get in with the driver, pull all those screws out, and then after getting all the screws pulled out, you can see them pulling more screws out here. Then we would mark out the perimeter of each one of these sheets, and then with a saw, cut the overlay so that that would completely separate that sheet from the deck down below. Then we could pick it up and look underneath and find out what the heck was going on. Now, in this particular photo, and I couldn't find a good photo that showed it, one of the problems that we had is you can see those dark little dots right there. Those are where the screws went down through into the bottom panels. And this one is real close to the edge right there. And we had a lot of that going on, but we even had several of them where they missed altogether. What the contractor did is, because the deck was so wide, and once all of the top sheets are down and he starts putting the screws in, you're blind. You don't know where those panels are down below. And so the directions were to chalk a line from end to end and then follow that line. Well, the contractor found out it was a lot faster and easier, rather than chalking each line, to just run a string line. Well, when you run a string line, if your drill machine hooks that string line and starts pulling it, you're going off in whatever direction, and that's what happened in a few applications. So we ended up actually having several screws miss the bottom panels down below, and that did not help our situation at all. But we found that moisture was getting in there, and moisture and grit, once it gets in between those two, does a lot of damage. So we were finding that a lot of damage was going on down below. So one of the things that we decided to do is replace some of the damaged top sheets with new top sheets. So this is a new top sheet that we're putting back down in place of the one that we removed at this location. And instead of using screws, we did a little bit of investigation, and we found a product out there. It's a rivet, an oversized rivet. They actually call it a BOM, and BOM stands for Blind Oversized Mechanical System. And we tested this. This is an application in the shop where we tested this connection system and found that it had more than twice the tensile capacity in the connection between the two FRP sections Of course, the FRP is what fails in tension loading on this because it is the weakest part of the system. But this seemed to be a lot better connection system to us. And so we decided to replace these panels with these rivets. And so here we are popping these rivets in on this new top sheet that we put in on that deck. And so you can see here, the top part here, this is a new sheet with a new overlay that they put on. And then this is the old sheet that went back. And each one of these spots is where we drilled out and put the rivets in, connecting the old sheet back down. And we wanted to see how much of a difference it made putting the old sheet back versus putting in a new sheet. And what we did find in time is that with the rivets, when we just tore this deck out this last year and replaced it, it failed so rapidly because this was back in 2012. So it didn't last very long. But all of the sheets that we replaced with new and riveted them down, they were still performing quite well at the time we replaced the deck. The problem we had, though, was the damage was so widespread and the cost of repair was getting extremely high. To try to do the entire deck was just too much. It took us about 9 months to investigate our problem and come up with solutions that we kept modifying as time went on. And the damage was just at a much faster rate than what we could do the repairs on. In time, this is what the deck started to look like. So everywhere where you see all these repair patches, that's where we went in, removed screws, put in these rivets to secure the top panels down. Starting to look like the Frankenstein deck here. And you can also see, like right in here, you see a little bit of green along that joint right there. What we also found is that using an adhesive in addition to these rivets was really the best repair that we could come up with. And the glue that we used was a Plyo Grip 7000, I think is what it's called. Really good stuff in FRP applications like this. Over time, we were finding that there was a lot of damage. Actually, let me jump forward and see if I can find that slide. Yeah. Another problem that we were finding is if the screws never hit at all, or the screws started to work loose, the lack of connection between the top sheet and the bottom panels would allow the flange of the bottom panel section to flex at the web to flange connection. And with that flexing, it would actually, over time, develop these cracks that you see right along in here. And once that started to happen, even with good connection, this is a blind rivet here, even with the good connection between these two, if this had significant damage, then it would start to work that and continue to deteriorate. And so what we decided to do to fix that problem was to inject some foam down into the deck panel system itself and use this glue between the flanges and the top sheet to secure everything down. And I have another photo. Yeah, initially what we tried doing was drilling small holes to put the foam in there. But what we were finding was there was so much debris and waste material in there that it was actually easier to go in and cut up sections of the deck, fill in the foam, and then cut the excess foam and get it right to the top, and that would actually fill it the best. And here we are doing some additional packaging. Now, over time, and let's see, I think I have another photo that shows that better. Over time, as more of the flange to web connections started to break down, we started to lose the top flange altogether. And you can see right here, all the flanges are gone. These are 4-inch square aluminum tubing that we had to go in and insert these. This is towards the tail end of all of our maintenance before replacing the deck. We would actually go in and put little tabs on the edges of these tubes, glue them down in, and then use huck bombs to rivet those down, and then put the top sheet on top of that, and then drill into the aluminum tubing to huck bomb the top sheet down directly to those. And so as damage progressed, our repair techniques and methods that we use had to progress along with it. And this is the process that we went through in an effort to maintain this deck. Now, this is a picture of the Broadway that I mentioned earlier. And I was out on the Broadway one day when we were doing all the repairs on Morrison, and I heard a very similar slapping sound that I'd heard on the Morrison. And so we went in and did an investigation on Broadway, and we found that that same FRP deck system was experiencing very similar problems that we had on the Morrison, but not near at the rate that it was happening on Morrison. When we put the FRP on Morrison, this was for the light rail. Those are the light rail tracks that you see in there. This was a city contract job where they had come in and put this rail system in there, and we got an IGA agreement for a 5-year warranty on their FRP deck system on Broadway. The day I discovered this problem was 4th year and 11th month. I mean, it was right at the end of our 5-year warranty period. But we still had enough time that we went to the city and we said, hey, you got a problem out here on the bridge with the FRP deck system, you need to fix it. And so the city went to the contractor and said, you got a problem out on Broadway, you need to fix it. This contractor's response was a little bit different. They said, what do you need us to do and how soon do you need us to get in and take care of it? And that's exactly what they did. They stepped up to the plate, they came in, and when we went to the city, we said, you got a problem, but we know how to fix it. Because with everything that we had learned on Morrison, we were able to apply that to Broadway, and we knew the solutions and the best repairs to apply to Broadway. And so it took the contractor about 4 days to go in and implement these repairs to Broadway. And that deck to this day is still performing quite well and is doing very good. So lessons learned from that standpoint, and fortunately we were able to apply it and save one of our decks. Unfortunately, we couldn't save both of them. FRP does have a lot of very good applications in bridge, but right now with the potential problems for having traffic actually impacting the material, there's still a lot of issues to get resolved before FRP is going to function well as a bridge deck system, but that may be in the future.
Friday, I did this exact same issue, so I would like to get a hold of you before you leave.
Okay, yeah, what was interesting is Florida had a very similar issue on one of their bridges out here. And it was interesting because when we were out there working on these problems, word got out, and I got an email from, and I don't remember the gentleman's name, I wish I'd held on to it, a gentleman from Florida, DOT here, and he sent me some pictures, and I thought, how did he get pictures of my bridge? It wasn't, it was his bridge. It was the same exact problem.
The question there is, the rest of Broadway is holding up. Is that holding up fine?
Broadway is doing rather well.
Right, and that was a different, it's an FRP deck, it's a different manufacturer.
Well, on Broadway, the first deck system that we put down was a single panel deck system, and that is actually still out there on the bridge, and it's on the outside lanes. On the inside lanes where the tracks are, that is the two-part deck system with the screws screwing the top sheets down to the bottom panels. And that was actually, now there was 2 different pultruders that made those panels. The supplier of it went to a different pultruder to make it. And so it was 2 different pultruders that actually made those panel systems. And that was part of the issue. But the bigger issue, because the manufacturer of this deck system had problems long before we ever had them come out on our bridge.
Right.
So,
yeah, and I guess my one other comment there again, and I am an FRP deck supplier, and this supplier is out of business. They only did a handful of bridges in the United States, and again, there's material inherently is not bad or good. It's how you design and work with it.
Yes.
And my other comment I say is when you're at home and you're repairing something, Generally, if you're gonna repair plastic, you don't screw it together with lag screws.
Yes.
Okay?
Yeah.
And the same fundamental structural things apply, and then it's magnified when you're hitting it with big trucks.
Yep.
So that's my one thing there, is there's a
Yes.
lot of good FRP decks out there, but I agree, you ended up with a problem supplier.
Yeah.
Time for one more question.
I just was curious on the time frame from initial installation to going through all of your repairs and then the Broadway Bridge here. What time frame are you looking at?
So Broadway, the second deck system went down in 2010, I believe is when that was completed. Morrison was completed at the end of 2011, first part of 2012. We started seeing problems with it almost immediately, so it was about March of 2012 was when we began our investigation, and that went pretty much through the year of 2012, and it was in 2013 when we really started ramping up implementation of some of the fixes and the repairs, and then it was somewhere towards the end of 2014 when we identified the problem with Broadway and got the contractor in there to take care of that problem.
Wow,
So-
okay. And you say that both of them are doing relatively well now?
Well, no, Morrison, it was just a
Too far gone.
patch. Yeah, it was too far gone. And we actually replaced that deck. We just finished up that contract. And it was actually the same contractor that tore out the FRP and put in the new deck that did the Broadway deck and did a really good job on it. And we're very happy with that contractor. But the Morrison now,
What type of deck did you go back
so we
with?
went back to a steel grading deck, but this time we filled it with a lightweight concrete, and then we did an overlay very similar to what we put on the Morrison before, the epoxy aggregate overlay. But that deck came in at about 2.5 times the weight per square foot. And so it was a lot heavier.
Yeah.
And so that opened up a whole new can of worms. And that's another presentation that
Right.
Matt's very familiar with because he just gave it. But yeah, that's a very fascinating process of what we had to go through to put that deck system on that bridge.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.